Hi, I'm Shweta Gumpena, and I'll be demonstrating the deployment of my Akka HTTP application on AWS EC2. So this is as part of the third assignment of CS 441. Here, we're demonstrating a policeman and thief graph game. So all of the detailed description about running this application is mentioned in GitHub. So in this homework, we have to construct HTTP requests and responses for playing the policeman and thief game and implement the game server using microservices that receive these HTTP requests and reply to them using the rules of the policeman and thief game. We will then deploy an instance of the game engine on AWS EC2 and configure it to enable clients to play the policeman and thief game. So the game should be played by the following rules. So initially, we can place a policeman and thief at any random place. If coincidentally they end up being on the same node, game is over before even starting. So to ensure this does not happen, I am randomly placing the policeman in one of the node of the perturb graph, and the thief is placed at the farthest node from the policeman. Then each player takes turns moving its corresponding P or T using directed edges between nodes. Some nodes have the attribute valuable data, and if the thief ends up at a node with this attribute, then he or she wins the game and policeman loses the game. If thief is initially placed at the node with the valuable data, then thief wins by default and the game restarts. However, if police and thief end up at the same node, then police wins the game and T loses it. Basically, the police catches the thief. If either policeman or thief end up at a node where there are no moves available, then the stuck player with no available moves loses the game. So this is basically the case in which the graph does not have any more successes. It has reached a dead end and that person cannot move further, so that person loses. And then policeman and thief query the perturb graph to obtain information about their own and the opponent's location nodes and the adjacent nodes. Each of these nodes comes with some confidence score that the node or the edges that lead to it were not perturbed. If a player makes a move in perturb graph that cannot be performed in the original graph, then he or she loses the game, in addition to the basic game rules. So I've explained the technical design here with the step-by-step and file-by-file explanations. So there's routes and actors. I'm using Akka HTTP here. So just a brief walkthrough of how the code base looks like. So in the source main, I have the main file, which is the starting point of the application. I am passing the input parameters using the configuration. So it is nothing but the original graph, the perturb graph, and the output directory. I am first loading and creating the graph using Guava's graph builder, both the original and the perturb graphs. And then I'm initializing the actors and routes from Akka. And coming to the routes, so I have a couple of routes here. First is just a health route to check if the server is up and running. And then is a move police route to move the police, move thief to move the thief to a successor node. And then a state route to get the current state of where the police and the thief are. And restart is to restart the game. Subsequently added another functionality called autoplay, which basically when this endpoint is hit, it automatically plays the game and gives us the logs of where who has gone and finally who has won the game and due to what reason. And then my actors basically has the state management as well as the logic for moving the person. So initially, the police is at some random node, and the thief is at a farthest node from the police. And these are the implementations for move police, move thief. Okay, next, so I've already created a jar and I have uploaded it to S3. So in my assignment 3 bucket, Let me just clear out the previous output. So in my input folder, I have the original NGS, a perturbed NGS. And then in the jar, I have the jar which I got by running sbt clean compile assembly. And then now to actually deploy this on EC2, let me just open this in a new page. So launch instance. I think before this, let me run the application locally and let's see what it looks like. So I'm running the main file. So both the graphs have been successfully loaded and the server is online at port 8080. So coming to Postman, which acts as my client, let's first see if the server is up and running. So I'm just hitting the health route, localhost 8080, and we got a successful response. And to get the current state of the police and thief, so the police is at 35 and thief is at 33. And now I would first move my thief. Thief is at 35, police is at 35, thief is at 21. Then I would go ahead and move my police. So we got invalid move at 48, game is over, thief is won, and restart the game. So the game is practically over at this point. If I try to hit it again, I just get a standard message saying game over, thief is won, restart the game. If I try to move the thief after the game is over, even then I just get game over, thief is won, restart the game, and similarly with state as well. And I can go ahead and restart the game. The game is now restarted. Now if I hit state, now the police is at a new node and thief is also at a new node. Now to overcome this method of like continuously hitting different routes to move the person, I have an option to autoplay the game. And let me first restart the game. And then let's autoplay the game. So this is a final message that thief has reached valuable data at 49, the game is over and thief has won. So if I go ahead and check my resources output folder, a new file is created called results, which basically gives the results across the thing. So this is a game that was the autoplay game. So the police was at 16, then goes to 13, and then the thief was at 13, and then this other steps of steps the police and thief has taken, and the thief has reached valuable data at 49 and the thief has won. So this file would then be created. Now if I stop this and go ahead and create my EC2 instance, I'll call it Akka HTTP 441, and I'll use Ubuntu here. I'll go with the free tier of T2 micro. Key pair name, I've created a key pair for this. policeman thief, and I'll select an existing security group, created a launch wizard, and I think everything else looks good. I will launch the instance. Two instances. Still pending. Once it starts, we can go ahead. So I would also like to add an IM role because I would be writing the results back to my S3. So go to security, sorry, instance. That's here. So actions, security, modify IM role. I'll choose the EMR. I had created a role which basically has full access to EC2. I'll update this IM role. And then I can go ahead and check the IM role is added, and I can go ahead and connect it. I'll do it through SSH, and I'll do this from the terminal. So I need to give the paths to the PEM file, which I would be doing. So this is where my PEM is, get info. Copy as path name. I paste it here. So I'm now into Ubuntu. Then so I would just go ahead and do sudo apt update and sudo apt upgrade. So this is to update the local packages to the latest versions, and it upgrades the install packages to the latest versions. Okay, this is done. Let me check. I would need Java and SBT to run this program. So let me check if Java is present. Java is not found. Let me install the OpenJDK 11. Now let's see the Java version. Java 11 is there. Next, I'll install SPT. So I have this command to install SPT, which basically fetches it from this site. Then it extracts the files of SPT. And these extracted files are moved to this location. Next, I would do bash. And then source bash reloads the updated changes. One second, let me just redo this. Okay. Now, I would have to load my jar. So wget, and I'll give my jar's location. I'll give the URL. -p, and then I'll put it in the /home/ubuntu/441. So I'll get the jar from S3 and store it in this directory. Now, if I do ls, I have the 441 directory. If I cd into the directory and do ls, I have my jar here. And then I will set the default port to 8080. Now, I can run the jar. So the jar is present here. So I will do java-jar and give the name of my jar, followed by the parameters. So the first parameter is the original graph. I'll give the URL, followed by the port of graph, followed by the output directory. For this, I can give the S3 URI. So this should be output. So my server is up. I can go to Postman. So I need to get the host. So this is the IP address that I'll be using. So now I can go ahead and play the automated client game. So if I hit send, so it says cannot move further at 10, game is over, the thief is won. We can go ahead and see how the game has gone through. So this is my output directory that was just created, 914, results.txt. And if I open it, so first the police was at 28, thief 40, then thief made the first move, then police made the next move, and then a thief made the next move. And then police had to make the next move, but a 10 must have been a dead end, so it couldn't move further. So the game is over and the thief has won. So if we actually go and see the perturb graph, I have a picture of the perturb graph. So at 10, let's see, where's 10? Yeah, so 10 is like a dead end, so the police couldn't move, due to which the police game is over and the thief has won. So another explanation of the output, I've taken one instance over here. So the initial state was police was at 48 and thief was at 33. So police was at 48 and this was how they went: 48 to 29 to 26, 48 to 18 to 29 to 26. So this was how the police went, and this was how the thief went from 33, 21, 23, 15, and 49. So the ones marked in orange are the nodes with valuable data. So the thief has come to the node with valuable data, which is 49, and the thief has reached valuable data. The game is over and the thief has won. So this is an overview of the project. Hope you liked it. Thank you.